Hi, my name is Jeremy Walker. I'm a developer advocate here at Google, and today we're going to talk about the 3 flaws in software design with Max Cannon-Alexander. Max, why don't you introduce yourself?
Hi, Jeremy. My name is Max, and I wrote a book called Code Simplicity, which is published by O'Reilly Media, and I now work on developer productivity internally at YouTube.
Great. So these 3 flaws actually relate to the law of change, and I thought it'd be good if you kind of talked a little bit about that first. Would you mind just giving us a little bit of details on that?
Sure. So in my book, Code Simplicity, I go over the fundamental laws of software design. And one of them is the law of change, which states the longer your program exists, the more probable it is that any piece of it will have to change. And basically what this really means is that if you want your system to continue to be helpful to people, you're going to have to keep changing it. Obviously software doesn't change itself, like people change it in response to demands, but if you just sort of look at it objectively as though there were no people involved, it just looks like the software has to keep changing. And so that's the law that you can apply. You can expect basically that you're going to have to keep up with change, and that the probability that it will change, of any piece of it will change, increases as time approaches infinity, basically.
Great. Well, why don't we get into the first flaw, which is writing code that isn't needed.
Sure. So the first flaw in software design, so I have these things, and they're called the 3 flaws of software design. And these are sort of the major categories of errors that developers make when they're trying to design software. And the first one is writing code that isn't needed. Now this sounds like another rule called you ain't gonna need it, which is very popular. It comes from extreme programming and from other philosophies. But the problem that I have with that phrase is that it's a little bit misnamed, because it's not really about whether you're going to need the code as much as about whether you know how it needs to be designed now. What really matters is that what you want is you want really well-designed code that's maintainable into the future, because you want to be able to cope with change, right? Without getting yourself into a situation where it's impossible to deal with that change, or where it's hard to change the system. And what you're writing for is you're writing for requirements. And in a way, it's impossible to really know what those real requirements are really going to be until the actual situation arrives that you need to write the code for. So I don't say that you ain't gonna need it, but I just say you shouldn't write code that you don't need yet, or you should wait until you need it. And the reason is that you run into all kinds of problems, right? So let's say you've written something that's going to reverse strings, right? Like that's its whole purpose. That's the only requirement that you have. And you decide, well, you know what? I like reversing things. Reversing things is easy. Let's make it also able to reverse all of the pixels in an image. Why you did this, I don't know. You just thought maybe I'm going to need it someday. I don't need it now, but maybe I'll need it someday. The problem is that that significantly complicates your code. It makes your tests harder to write. And probably by the time that you actually need to reverse pixels, you'll discover that you needed something completely different. Like the code that you wrote didn't perform the right way, and it's just not appropriate. Like you thought you were going to read JPEGs, and really you need to read PNGs. It's just going to be the wrong code. Or it's possible that it was the right code, but that because it wasn't used, that by the time you actually get to that point, it's rotted and it no longer works, and you're going to have to change it anyway. So you might need to redesign it. And so ultimately, people think, well, I'm saving myself time by writing this before I need it. But ultimately, you're not saving yourself time, because first you wrote something that you didn't need, and then you wrote something that you did need. So you actually did basically the work twice, or maybe 1.5 times of the work that you needed to do. And you're adding complexity, and you're trying to, and in a way, a lot of what people are trying to do when they do this is they're trying to handle all the things that could happen in the future, but you don't know all the things that could happen. And I'm going to get a little bit more into that in another flaw. And these flaws are a little bit related. Sometimes they overlap a little bit. But one of the errors that people are making when they try to do this is they're trying to handle every possible thing, and they can't. So there's all kinds of different ways to do this. It's very common to see people write whole classes or functions that they don't need, right? So they've written a whole class for, maybe they wrote a whole class to handle the reading pictures because they wanted to reverse pixels in the image, right? But a lot of the time, what I see is just little lines of code that you don't need. People are doing checks that they don't need to be doing. I see this a lot when I'm doing code reviews. In fact, one of the most common comments that I make in code reviews is, you don't need that yet. Or do you need that yet? Or what's the requirement that's actually driving this particular piece of code? And it's amazing how much simpler you can make code by just continuously asking this over and over and over is, do you need this? Or when is this going to be needed? Or do you need it now? And the rule that you can apply to avoid this situation or to handle this flaw is that you don't write code until you actually need it, and you remove any code that isn't being used. So that's the second part, is the part that gets occasionally missed with the YAGNI, or the you ain't gonna need it rule, is that once code is dead, it should just be deleted. And people think, well, I don't know, maybe I'm going to need that dead code again in the future, but that's why we have version control systems. If you really need it, you can pull it back out of the version control. Just delete it now. Many code bases have gotten into extreme complexity just by leaving around tons and tons of dead code, and now nobody wants to refactor them because they think, oh, look, I'm going to have to refactor all of these things, when really 90% of those things are dead code and should have just been deleted, right? It's much more approachable to solve the problems of a smaller code base. In addition to the fact that you don't have to fix the tests of code that doesn't exist. There's all kinds of advantages to code that doesn't exist, or code that isn't written.
Yeah.
So to demonstrate this principle, what we're going to do is we're going to do an example code review. And this code review is a little bit exaggerated. Like the situation, the code is worse than code that you might actually see. And we're going to do a few more steps than you might do in a real code review, but we're going to do it to demonstrate the principle. So we have this requirement for a piece of code, and it says parse a date string that looks like YYY MMDD and return an array with 3 integers. The first integer is the year, the second is the month, and the third is the day. This is internal code in an application. It's not a library. We're not providing it to the outside world. And like I said, it's a little bit of an exaggeration. So let's look at this over here. So the code that the developer writes and submits to you, the code reviewer, is this mess. So up here it's got 3 constants that say, this is the year, this is the month, this is the day. It's preparing to parse a year string, a month string, and a day string. It has comments for every line of code. And you can see it's going through. If you're not familiar with Python, enumerate means give me both the index and the item from an array. In this case, we're going through the characters in a string. And it checks, OK, if we're in the first 4 characters, this must be the year. And then, oh, is it a valid integer? We're going to check that we have a hyphen in the right place. Next 2 characters have to be the month. If they're not digits, then we should raise an exception. OK, and then we're going to figure out that this is the month. Now that we validated that all these things are right, that the format is right. Oh, and if the string is too long, we raise an exception. Now we check if the whole year is an integer. And then if that's, we throw another exception. And then finally, we create an integer for the year. And then finally, we create this return value array. And then we set each thing in the return value array, and then we return the return value. OK, so this is obviously a disaster, right? And a lot of the time in code review, when you're presented with a disaster, it's hard to know where to begin. It's just frustrating. You say, well, just go away and don't ever write code again. But that doesn't help you, and it doesn't educate the person whose code you're reviewing. So I want to try to take some tack, some direction that we can do with this. So the first thing that I'm going to tell the developer is, the first thing you don't need in this file is all of the comments. I didn't need any of those comments. I can read code. You told me what every line of code was doing. Surprisingly, the code became considerably more readable. It's not good, but if you look through it, it's much shorter. We lost about 20 lines. It's about 55 lines now. The first one was 71 lines. And you can actually kind of start to tell what's going on. So now you can see that there's another, you can start to see the next problem. And the next problem is, we know actually, so we did some research, we investigated this, and we said, your input doesn't include any years, months, or days that are out of range, which means there's no like 13 for the month, there's no 32 for the day, and there's no -1 for the year or anything like that. And what this represents is a really important principle, which is that it's really important to find out what your actual requirements are. A lot of the time, developers assume requirements, and then they write code for those assumed requirements. And I see this a lot. In fact, one of the most important things that I feel like I do when I'm writing code is ask a lot of questions to people. Go and say, well, what does this actually need to do before I go and write it? And I find that allows for a lot of simplification that I didn't otherwise expect. Because sometimes you think, if you don't know, you just assume that, like, for example, there's a lot of inputs that you could get. But when you actually go and find out, you discover there's actually very few inputs that you could get, and your code can be much, much simpler than you thought.
Yeah, I thought that was really good in the book. Like when I was reading it, like I think I always tend to overthink. Like I've got to check all this stuff, but then I was like, oh, that's a good point. You should really go back and ask, like, is the input coming in? What is the range? Like, do I have to check everything? And most of the times, I think you don't. So.
Yeah, and there's actually a blog post that I wrote called "The Secret of Fast Programming: Stop Thinking," which sort of goes over all of the ways that you can get information without having to sit there and think about it, and also about how that improves productivity. And this is really just a sort of a facet of that, a piece of that, or an aspect of that, which is that the information that you need for development is very frequently not in your mind.
Oh, okay.
Right? And so inventing it or using your mind to get it is the wrong tool.
Yeah. Okay, that makes sense.
Yeah. And so also, if we go back to the code here, we also note that if you remember from the original, he checks that every individual digit is a digit, and then he checks that the result of all those was a digit. It's not like, well, you don't need to do that. That's not necessary. And so this is we're getting down to almost one page of code now. It's starting to become readable. I can almost tell what's happening here. Now we're at 41 lines. And so our next comment of things, and all we're doing is just applying this exact principle over and over. All we're doing is just continuously saying, do you need this? Do you need this? Do you need this? Or telling him you don't need this, you don't need this, you don't need this. So now we can say, it's always integers in the year, month, or day position. So you don't have to check that they're integers. You don't have to validate their integerness. And now it's like kind of reasonable, becoming more reasonable. And your input always has hyphens in the hyphen position. There's never any other character. Like we're kind of getting closer to something that the developers should realize at this point, but maybe they haven't. And I'll tell you what that is when we get to the last point. And now it's 29 lines, and relatively straightforward. Getting even more straightforward. And also, so now we're going to say you never have strings that are too long. So there's never a string that's longer than a date should be. And also, this is Python, so if you want to return 3 values in an array, you can actually just do this, where you just write a tuple. Oh, you don't need to create an array and then set all of its values. So now, hopefully the developer has thought about this, but maybe they haven't. That what we're telling them is your input is always well-formed. So you don't actually need to do any validation whatsoever. All of your validation is unnecessary. It's very possible that this would have, in a real code review, this would have been our first comment. Mm-hmm. But we might not have been able to see that because there was so much complexity that you might not have been able to see, like, oh, what are all the things that we can eliminate? You might have needed to sort of go through this iterative process with the review in order to actually be able to figure that out. But the ultimate thing that we're saying, your input is always well-formed. You don't need to have a loop. You don't need to have a state machine. None of this is necessary. You can write this whole function in 2 lines of code, and here they are.
Perfect.
And so that is our code review, and that's sort of an example of how you would apply this law in your actual development. So that completes our discussion of the first flaw in software design. Let's go to any questions.
Yeah, so I actually had one question. I always like real-world examples, and you gave a pretty good one in the book, which I thought would be good to cover here. So can you talk about that? It was with lists, I believe.
Yeah, so this was actually something that I did. So I worked on a project called Bugzilla, which is a bug tracking system. And so there's drop-down fields in Bugzilla, right? You can choose like what the severity of a bug is or what the priority of a bug is. And I was like, well, you know what? There's all kinds of things we want to do. We want to allow people to rename them. And right now we're referring to all of them by strings in the database. We're referring to other strings. So I was like, oh, no. All right, I remember what it was. It wasn't that we wanted to rename them. It was they wanted to be able to turn them off or turn them on, right?
Right.
So I added all of this code, particularly at the database layer. I added database fields to say, is this field active, right?
Yeah.
But I didn't actually implement it. I just like threw in a bunch of database stuff because I thought, well, tomorrow I'm going to write the change that enables it in the front end. And then, of course, tomorrow something crazy came up and I had to work on this, and then I totally forgot about it and I had a million more important things. And then 3 years later, somebody comes along and is like, what is this? This doesn't make any sense. And also, in those intervening 3 years, we must have had at least 10 bugs filed by people who had manually gone in and changed their database. And some of the code had checked if the field value was active, and some of the code hadn't checked if the field value was active. And so it caused incredibly confusing bugs. People would report these weird bugs like it shows up in the search interface but not on the bugs, or it shows up on the bug editing page but not on the bug creation page. And finally, when somebody did implement the ability to disable values, they actually had to do it a completely different way because I had named the database fields in a way that was inconsistent with our later convention. So they had to rename all the fields in the database and then write a completely different implementation because our framework had completely changed in those intervening 3 years. And it ended up being a total waste of time, which did nothing but cause bugs and confusion for anybody who ever went in and tried to do this manually. Because people, I mean, Bugzilla in particular was a product where everybody wanted to customize it. People understood database design, and they would make their own changes to it. And so they would look at the tables, and they would actually see this, and they would actually try to do that. And it just caused nothing but trouble, and it did nobody any good, basically.
Yeah, I thought that was a great example. Well, great. Well, hopefully that kind of gives you a little bit of a taste. That covers the first of the 3 flaws in our series. Please join us for the next video.